thank you all for coming tonight. This is our UI Explorer seminar series, which happens once a month on Thursdays during the academic year. And if you aren't already on our mailing list, there is a clipboard on the table outside, as well as several handouts, information to take home, as well as cupcakes and lemonade outside, so please eat up. We are excited to be a part of the GIS Day celebration. Hopefully this will become an annual thing that we participate in, and so we have three very interesting speakers tonight, and I'm going to turn it over to them and let them get started, but thanks again for coming.
Okay, so apparently we're interesting. That's good to know. I hope my project is as interesting as I am as an individual, but my name is Adam Skibbe. I am with the Department of, the department formerly known as Geography. It's now Geographical and Sustainability Sciences. I've been back in Iowa City for about 5 weeks, but I came back as basically a GIS administrator. My position is to sort of help with outreach and trumpet the GIS cause on campus. Since I've only been here 5 weeks, I'm going to be presenting some work that I have brought with me from K-State University, where I was most recently. After I am done, Colin Gordon will be presenting. He's from the Department of History here. And then Rick Havel from Johnson County. I'll get started and I'll remind you who they are after I'm done. So my presentation is on where and when the buffalo roam, using GPS to track bison through the tallgrass prairie. And this is Kanza Prairie. This is where I came from most recently. It's right outside of Manhattan, Kansas. It's a beautiful, beautiful prairie site, as you can see. And we have bison. So the site, Kanza, is in this. I apologize for the hectares as opposed to acres, but this comes from scientific research, so I didn't want to last minute change it. 3487 hectares, of which 963 are in a bison area. This area right here is where we allow the bison to reside. It is basically fenced in, and they have free roam within that area. Now, we do burn, or we did when I was there, burn Kanza on a rotational basis. Effectively, we would take 1, 2, 4, and 20-year burn intervals where we would burn the prairie and test out how that impacts, biodiversity and that sort of thing. In that area on Kanza, we have about 300 units, 300 animal units, which isn't exactly 300 bison. It's an animal unit for an adult male is actually considered more than one, and then for a child it's less than one, so somewhere in that range though. So, one of the things that's been done on Kanza is, starting in 2006, we took about 5 collars. These, which I cannot express how large they are with that, there's no scale, but they are enormous, they're like this big. And we put them on 5 of the female bison, matriarchs of the group, and we started tracking them in 2-hour time periods with GPS. This unit right here is the actual GPS unit, and for scale purposes, it's about this big. You can see this individual wearing one right here. When I left Kansas State, we had 15 animals with these collars on them. And we had ramped up over time. We went from 2-hour intervals, 1-hour collection intervals, to 30-minute collection intervals for GPS signals. And that just tells you where they are on the prairie, and that way we can track them around and see what they're doing. I'd also like to add, if anybody has any comments or questions as I go, feel free to just ask. I'm not going to be offended if you step in. The idea behind the matriarchs, tagging the matriarchs, basically we have a representational sample of the entire group of animals, with the exception of the bulls, which are typically culled out anyway, so there are a handful of bulls left over just because they cause problems. So the question is, where are these bison? This is 5 years worth of data. This is actually 2006 to 2011 data. And they cover everywhere on Kanza, within the bison area. It's ridiculous. Like, when we looked at this, it's like, okay, this is great. What does this tell us? So what you actually have to do is just start breaking it down a little bit. So we've got the whole where, they're everywhere. When were they in each of these locations? And perhaps, we can look at those on a time frame. So subsets of the data show shorter time scales, basically what we can get at from that. The distribution really changes on a year-to-year or even month-to-month or week-to-week basis, and I'll get into why that is here in a second. But you can see from the different years, they are really moving around the site and more intensively grazing in different areas. So we've got that, but why? Why? I mean, what's the point? Why are they moving around? What are they doing there? What's driving them? Well, the part I left out is we actually kind of knew this going in, but it doesn't make for as good of a story if I say, hey, they like good forage. So they like good forage. And since when you burn a prairie, the nutrients go back into the system. When it greens back up, it's a good place to go eat if you're a bison. So we knew this. We also know where we burn every year. We keep track of all that stuff. So what we were seeing is a very strong response of bison movement into recently burned areas that have recently greened back up. If an area has been burned every year, the nutrients that go back into the system are not quite as high. So 2 years are more preferred than 1 year burns, and 4 years are even more preferred than that because there are more nutrients in the system and it's just higher quality. They don't like us using the word quality because it doesn't really mean anything, but it's better food. And they tend to use the unburned areas in the wintertime. So real quick, the red is the March burns for 2011, and the orange is the April burns. And I'm just going to go through a series of slides real quick. That one was out of place. This is just 1 year sort of in the life of the bison that we've got tagged. Phase 1 means there's a thing called roundup every year where they pull them over to the western side of the site and say, make sure that everybody's got their shots, make sure that if we have to put on new collars, that's when we do it. And then we slowly release them into the rest of the site. So you can track through time here. These are about 2 weeks at a time, starting in mid-October. So you get October, early November. They're spread out across the site once they're let free. Into December, same sort of deal. They're just moving around. Not a whole lot of anything going on. January, February. Then you get into March and April here, and they're going back to some of these areas that are starting to green up a little bit. Now, this is where you see the real awesome stuff. This is late April. Here's early May. Right after these burns occur, they are just on it. They go straight to those areas and they eat that good forage. And as you see, they're a little bit up here, but really strongly in these orange areas. And then as this gets burned up here, same sort of thing. They're moving into those areas. Now you're going through the summertime, and then by the time you get back to senescence, when the grasses start dying down and there's no more green, it's just dead grass at that point in the late or early fall. As you see, they're starting to disperse throughout the landscape. So it was pretty sweet. Now that we've got numbers on all this and how they actually are using the site, we have statistics to back this up. But this is the pretty picture that goes along with that. And this is what the GPS and all the GIS work that we threw into it was able to do for us. And really quick, since I put this out of order, I did want to say we did use, in addition to our GPS locations, we have remotely sensed data that we can use as well. We use MODIS, which is a remotely sensed sort of coarse satellite product that can give us this NDVI, Normalized Difference Vegetation Index, which is what you see here. And as you can see, it's not a great example, but this is a pre-burn and this is a post-burn. So you can see this area here that's greened up, and then you can see the cluster of animals that are using that area right after the green up. We also had hyperspectral flown, which is 1 meter resolution, super high resolution for the site, which we calculated our own NDVI and our own nitrogen content from. I will say that they do use those like we expected them to. I just didn't have time to actually do those maps since they're on my hard drive packed in my parents' basement. Just real quick, we've got some ongoing work that's going on with additional parts of this GPS data. One of them that I don't actually have a really good image of, you can see it here. And these here are bison trails. We've actually digitized all the bison trails on the site using aerial photographs and double-checked them using GPS via field trials to make sure that we get these highways marked. And that's sort of a work in progress. This wallow project is a little bit more interesting. These are all the wallows that have been GPSed on Kanza. We had a student go out and get all those information for us. And effectively what we were able to find is what types of areas they prefer and how the site is being used in terms of wallow. A non-GIS related study to this shows that actually a fair bit of their drinking water from isotopic signatures comes from their wallows as opposed to streams, which is considerably different than cattle.
So do they make the walls?
They do.
Okay.
Yeah, the definition of a wallow it's pretty general. It's effectively a flat area that they use, blah, 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 right? So there are historic wallows that they reclaim. There are flat spots that become wallows because they use them. But effectively, that's them wallowing, right? It's not like, you're not gonna find a little puddle that's a wallow. It's gonna be a little puddle that they go and do this in, and then it becomes a wallow. And that's all I brought for today.
Hi, this is Coach Bluter, and I'm here to tell you it's game on. The Hawkeyes are ready for the season, and we hope you're ready to join us. Order your Iowa women's basketball season tickets today. Call 1-800-IA-HAWKS or visit HawkeyeSports.com.
Show your Iowa pride, the Iowa Hawk Shop, where Iowa shops. The ultimate collection of Iowa Hawkeye merchandise, gifts, and apparel. Help support the University of Iowa. All proceeds benefit men's and women's athletic teams and student programs. The Iowa Hawk Shop, where Iowa shops. Show your Iowa pride. Call 1-800-HAWK-SHOP or visit www.hawkshop.com.
Hi. So I'm just going to introduce you to a web-based resource we're working on, and I'm going to try and do this live. But if the connection is too slow, I'll switch quickly to some screenshots and a PowerPoint presentation. This is a project in historical GIS. It's not really a completed project. It's meant more to be a platform for future work. And I just want to give you a sense of what we've done thus far and some of its potential. And this is a collaboration between myself and the Department of History, Digital Library Services, the Office of State Archaeologist, the DNR, the State Historical Society of Iowa. All have sort of contributed data and layers and ideas to this. So the idea here is to pull together an array of resources, historical resources on Johnson County, and host them on a Google Earth-based web platform so that you can play with those layers, pull them forward, analyze them in different ways. So the idea of doing, we started with digital Johnson County because, you know, it's here, there are very good resources. a lot of the layers were already well developed, but the idea here is that it's scalable, that you could do this for the whole state, but also scalable in the sense that you can just keep adding different kinds of layers to it. And what we sort of see this as, it's sort of the future of the historical atlas, that it should be this sort of interactive, updatable kind of product. Like most platforms for historical GIS, it involves bringing in different kinds of data. And one of those, particularly for historical GIS projects, are georectified historical maps. So this is an 1875 atlas of Iowa that we have in the background here. And as you can see, we faded it out a little bit so you can see the satellite imagery from behind. And this is done simply by pulling in a scanned version of the atlas, and then in the software, pinning it to locations that are common to both maps. Actually, it's surprisingly hard to find a common point because very few of the roads are there in 1875. The river's not in the same place in 1875. But we managed to do it. Actually, some of the streets in Iowa City are the most reliable way, starting point for that. And we do that on a number of scales. So we have countywide atlases. We also do it for county or townships. So there are 16 townships in Iowa City. This is Big Grove Township. It's a very high resolution scan. These are from subscriber atlases from 1900 and 1930. So they actually have the property owner's name and the acreage of the property and the like in there. And we also have in here for 1900 and 1930 a number of towns. So, we can look at Coralville in 1900. It's a little bit different. This is the 1900 mall, I think. And this was difficult to pin to the map because the river is in quite a different place. The other thing you also notice about older maps is they're often very cavalier about mapping the river, because what they really cared about were the property lines were, and then the river would be sort of an afterthought. So it's actually sometimes not a reliable element of the map. But we were able to use rail beds, which are visible in both maps, to identify these. The second thing, the second major kind of data that we're putting into this is basic sort of political, social data. And this is parcel data. So each of these squares is an independent sort of thing on the map. Let me just zoom in so it's a little bit easier to see. Oops. What we started with here was actually Rick's parcel data from Johnson County. So we have this sort of meticulous record of every parcel in Johnson County. And then by sliding in the historical maps underneath it, we backwards edited it. So it represents, and you can click identify and pick any one of these. And so we have the property owner's last name, his first name, the township, the acres that are listed on the map, the actual acreage that's measured by the software, which is a little bit more precise. And this is very rudimentary, but the idea here is that we can use this as a platform. We could go to the 1930 census, find this person in the manuscript census, and enter all sorts of things, like where their parents were born, how many kids they had, that sort of thing. We could also conceivably go to the agricultural census, or we have good aerial photography from 1930, so we could go in here and we could figure out what they were growing and map, the extent of field crops and that sort of thing. So this is the way it's, it's a nice sort of vessel for those future projects. Another kind of data that we're adding to the map that is very useful in historical GIS is what I would call point data, which are simply locations on the map. One of these, which we worked with the State Historical Society on, is their Flickr feed. Their photographs are geotagged. And so we can bring in the Flickr feed and the photographs show up where they are in the map, and then you can click on those and get a slightly bigger picture, or double click on them and go right to the Historical Society site and see what's actually going on. We've also, again, by pulling those historical maps underneath, mapped the location of all the schools in Johnson County in 1930, all the churches, all the cemeteries. And there's also this neat layer, this is not our work, it's somebody else's, where they basically scraped Wikipedia for any sort of spatial information. And so all these little red dots are Wikipedia entries where Johnson County, or a location in Johnson County happens to be mentioned. And again, all we have is the locations. But the idea is that we can eventually send students around and saying, well, there was a school here in 1930, go take a picture of it, go look in the Johnson County Historical Society and see what records you can find, you know, a graduation photo, and we can pin all of that to the location on the map. You could also, and do documents, so you could conceivably attach land records, for example. If we go way back to some of the first land transactions, the land office has the original deeds for many of these properties, and we could pin those to the map. Just give you an example of a couple of the other kinds of things that we brought in here. This is the General Land Office vegetation map from 1849, which we have here both in the original, so you can see the charm of the historical map if you bring it underneath, but we've also done it as a data layer as well, so that, you know, each of these, you can't read this, but it's field, swale, wetland, marsh, that sort of thing, distinguished. And eventually, what we can do, of course, is with using the subscriber atlases, do a similar map for 1930, a similar one for 1900, maybe a similar one for 1875, whenever we can scare up a subscriber atlas, so you can see the change in land use over time. So, you know, what's interesting in part about when you go back to the 1840s, of course, is the extent of the wooded area here in the, this is all oak grove for the most part. And so we can see how much, you know, by going back and forth between the current maps, you can see how much is left and that sort of thing. And one of the interesting data points, historical data points that connects this with the present is a really wonderful project that was done in 1918 and georectified, the map was georectified by our DNR library. And I'm just going to zoom in on this because it's a very nice high resolution map. This was a doctoral dissertation in 1918 in which the essence of the dissertation was he rode his horse around Johnson County and plotted every tree. But it's this great resource, right? Because you have all of these, literally, you know, every tree in Johnson County. And so you have, I'm always tempted to give that project to a student, including the horse, right? Which should be the good part. So, as I started with most historical GIS projects, these kinds of layers are really golden because there's a rich amount of historical information. Other things that we're trying to bring in, and there's just some sort of technical problems we need to overcome. The Office of State Archaeologist maintains a sort of public record of archaeological sites, and so we can have that as a feed in the map. There are a whole bunch of campus maps. The DNR did a project last semester where all of the historical maps of this area that have been in our paper maps that have been in our map library were brought up to DNR and scanned at a very high resolution, and we're in the process of georectifying those so they can become layers in this map. So again, it's sort of like a library repository, but you know, it seems that if you're going to have a map, you might as well have the map at a high resolution where it exists on the surface of the earth rather than in a drawer somewhere. And the nice thing about hosting it on the web in this way is that this is an entirely open access site. So anybody in this room can create an account on World Map, it's called, and you start with that empty Google Earth picture, but all of the layers that I've put up are available to you, so you can create your own site of Johnson County. And if you want to do, you know, primarily an ecological site, you could start with this and then pick up the GLO layer and go out and look for other stuff. Anything that I put on, anything that you put on is available to other users. And what's also nice about it is is not only those layers available, but effectively you have a wide array of researchers doing this on the surface of the Earth. And you could jump to, you know, Powaship County or Wapello County and see what is being put up and scale this up in that way. Once it's more fully developed as well, I think it's some place that we can have students, undergraduate students work on. We can ask them to do a project, and it might just be, you know, going to the parcel data and entering census information in it, so we get a sort of richer record. We also want to eventually set it up in such a way that there's a sort of open access, so that if somebody wants to go in and just look at their farm in 1900, there'll be a way for them to post a photograph, if they have it, of that farm 1900, and just sort of have that sort of crowdsourced curation build the site.
The Hawkeyes are rising. The Big Ten season has officially begun for the Iowa men's basketball team. The Hawkeyes will be heating things up on the court once again this Big Ten season, and you can help get Carver rocking.
Aaron's got to break out and look out below. Contested, it's showtime.
For tickets, call 1-800-IA-HAWKS or visit HawkeyeSports.com.
Can Hartley and the Hawks do it? Hartley sprinting back. It's caught, it's at the 5,
yes,
a touchdown. I can't believe it. A touchdown to Marv Cook. Holy cow. Can't believe it. 6 seconds to go. Hartley to Cook, and the Hawks have the lead.
Tradition.
Ambition.
Exploration. Inspiration.
You feel it when you step on campus at the University of Iowa.
The energy and pride of students inspired by our history.
And excited about our future. When you join the Hawkeye family, you're a part of it all.
Be a part of it.
Be a part of it.
Be a part of it. Be a Hawkeye.
All right, once again, I'm Rick Havel. I'm the GIS coordinator for Johnson County, and I'm also an adjunct lecturer for the Urban and Regional Planning Department, teaching GIS courses. We teach about 2, one in the spring, one in the fall. So I'm going to talk about something that's kind of evolving, and it's fairly new in terms of its concept. It's called geodesign. The practice of it has been done over the years, but the term is fairly new. So what is it? Geodesign provides a design framework and supporting technology for professionals to leverage geographic information, resulting in designs that more closely follow natural systems. So it's trying to use the technology to, when you're putting in a new building, for instance, or a new shopping mall or something, to try to look at the environment and do the best you can to preserve the natural flows or lessen the impact. So I first got exposed to a lot of the practices of what geodesign is about back in grad school. So, okay, it wasn't that bad. So in terms of the computers we had to work with, so we didn't have to wear suits. So anyways. The computers back in the 90s, early 90s, were more like this, Unix-based, somewhat dumb terminals tied into a mainframe system. So that's what I learned GIS on back in the 90s. And that's what I looked or stared at for a long time learning GIS. That was the interface to map production back in the early 90s, and actually still into the early 2000s. I still used this command line prompt in early 2000s to do work. But a lot of it, like I said, staring at white text got pretty intense at times. But I use that to do map production. So it's really hard. You're programming, you're typing in text, and then out comes a map. And we'll kind of talk a little bit more about that later. But back in grad school, as I was going through coursework in urban and regional planning and environmental resource management, it was kind of a joint program down in what's now Missouri State University. We started listening and seeing references to this guy, Ian McCarr, who in 1969 came out with this book called Design with Nature, where he promoted the fact that when we do design work, when we're putting in cities or communities, we need to look at that impact that has on the natural environment and try to make the output, the product, more in tune with nature. So it's not impacting that as much. So, and it inspired me because he started talking about overlay analysis back before computers really had the ability to do it. And how he would do it is take Mylar sheets and draw in areas that represented, such as watersheds or slope and soils. And you have multiple Mylar sheets, sometimes just black and white, either yes or no type thing, overlay it. The darkest spot is the hot spot, essentially. So and in this case, it's agricultural pollution. This bottom layer is what's derived, the potential for agricultural pollution is derived from the multiple layers that you see above it. Obviously, current technology makes that process a lot easier. But he was starting to promote this idea, to really push it, that we need to look at a lot of different aspects when it comes to design. So, in the late 2000s, or in about 2009, ESRI, Environmental Systems Research Institute, makes the GIS software, started having these things called Geodesign summits. They started talking about it. And it's really started to pique my interest because, once again, it goes back to what Ian was talking about. He's like, we got to look at the whole system. We can't just put a building in somewhere. And so it's gaining popularity. You're hearing a lot about this thing called geodesign. Once again, you're seeing the summits they're starting to be worldwide now. They used to be just in Redlands, now they're starting to spread some more. And then books are being published about this thing called geodesign. And it kind of gets into, and the key focus of geodesign is bringing multiple disciplines together. So it's not just like a scientist doing his work and moving on. It's a scientist and maybe the public, engineers and public officials all looking at the same page when it comes to this thing called geodesign. And it relates back to this proverb, if you want to go fast, go alone. If you want to go far, go together. And geodesign is about that. It's about bringing people together, getting them on the same page, encouraging collaboration, so that hopefully the output result, whether it's urban regional planning or anything else, is productive and effective. So to kind of provide an example of what this is, I'm going to describe a typical Japanese garden to you. And I want you to kind of build that picture of this in your mind. Okay? So you're looking at this picture in your mind. It has some boulders, rounded stone boulders spread throughout a garden that line a stream, a small stream. Okay, and there's miniature trees, bonsai trees, and there's other shrubs and flowers that kind of surround this stream as well. And a couple waterfalls feed this little pool fed by that stream. And in the background, there's taller trees that kind of help surround this garden. Okay? So kind of meditate, think about that picture for a while. But don't fall asleep on it. I know it's going to be relaxed. That's good. So, no matter how well I can explain that picture to my best ability, I can never get you to see the exact picture that I'm looking at, for instance. Okay? Does that make sense? I have to show you the picture in order for you to fully understand what I'm talking about. And so that's I think the overarching attempt of what geodesign is about. It's getting everybody to look at the same picture and have access to that picture. I mean, that's a key part of that too. So for the rest of this presentation, I'm going to talk about how Johnson County and its GIS can help in this thing called geodesign. How we can play our part in it. And there's other pieces to the puzzle, as you saw in that previous slide, with the people around the table. It's not just us that can do geodesign. We need other people to be involved in the whole land development process to help that design with the earth take place. So I'm going to kind of go through the different technologies that Johnson County has and the different resources that we have and how we can make them available to the public, to developers, to decision makers, to engineers, etc., to help geodesign take place in Johnson County. So back in 2001, I was hired as GIS coordinator to help implement and get GIS going in Johnson County. So when I got there, this was the primary method of map information sharing. Okay. Off to the left, you see an index map up on a wall. So when a person would come in asking about either their land ownership or adjacent land ownership information or zoning information, they go to the index map, they kind of, okay, this is where I live. And on that map, you can't see very well, but there's index numbers, and those relate to the map pages that you see on the right in this cabinet. Those are map sheets, hundreds of them, that get updated, or did get updated on a regular basis. And so they'd have to then open the cabinet, pull out the map sheet, and there you go. Very time-intensive project, or process. So now, in 2013, this is how you can get at that same information. The public can, the staff can, anybody who needs the information can. So obviously we can get it from tablets, desktops, products, PCs, and obviously smartphones. Another product we have to push information out to the public is our property information viewer. So, and it's obviously freely accessible. You go out to johnson-county.com, and off to the right you'll see a button called GIS Viewer. You hit that, and this interface pops up. And so one tool that this website includes is the ability to identify adjacent landowners or do a buffer analysis. It's kind of the GIS term. So as you can see here, we have a property that's selected. In our search tool, there's a spatial search option that allows you to create a buffer up to 500 feet. And as you can see, it's displayed here. So it highlights, okay, that's going out 200 feet. You can also use the search entities of tool to do an intersection of that buffer and identify every property that is within 200 feet. Okay? With that, we can display all the tabular, the attribute information that goes along with those parcels. And we can then export that out into a text file or a .csv file that then can be pulled up into Excel and then used to generate mailing labels. This process alone used to take hours to perform because the people that needed it, land developers, surveyors, had to come down to the county's office, pull out those map sheets, identify parcel numbers, write them down, go to a terminal, type in each parcel number, get the landowner information, write it down. Very time intensive. This is in the early 2000s. Okay. So a process that used to take hours and a trip to the administration building now takes seconds at your computer terminal. So what else do we have to offer for this geodesign thing? Lots of aerial photography, aerial historical. We're also pulling in the DNRs put together in 1930s on up to 2012, higher resolution imagery. There's the 1930s, so going back and forward. And this imagery you see here is now at 3-inch pixel resolution. It's the highest resolution imagery that we've collected. And we're working on collecting new 2014 imagery next spring. We also provide imagery, this bird's eye thing that you might have seen on Bing. We also have that at our disposal. We have an interface that works with that imagery. And you can see a series of tools up there. And these tools are not open to the public because of licensing, but this interface is. You can still get at this imagery through the interface. But those tools provide measurement capabilities. You can measure buildings, you can measure areas, distances, extremely well and extremely easy. So this imagery provides us not just one look like the two-dimensional straight downs do. We get the ability to look at these from 4 different angles. The information that we push out through ArcGIS Online, or I'm sorry, through the Property Information Viewer is available to anybody that has desktop software, ArcGIS desktop software. So you can pull those services in and use those as background information. As you see here, this is the interface to ArcMap, which is the GIS software that we use. So if you have that software, you can get at these services. We also make map information available to people in our office or in our county that don't necessarily need the heavy-duty software but still need access to map information, and we make that available through a product called ArcReader. It's a free-based product, so we publish maps that are dynamic, that change, that update, but it gives them the access to get at those maps without having to use the more expensive software. We also are developing and moving more towards this thing called ArcGIS Online, where we're pushing out our maps and certain applications to this site. Some for internal use and some for external use. So as we log into the site, we can pull up our content and look at the list of maps that we have available. We can pull up and display those maps. And this one was specifically done for our assessors county assessors department. So they need to display specific information. So then we can take that map and we can push it out as an application. So we make it more user-friendly, more viewable by the public or the staff using their iPads. Specifically, the assessors, that's how they get at this information. They wanted a map out in the field. And when they first started talking to me, they were talking about, okay, we just need to get the printout of this map or this area, these neighborhoods, so we can go out and check off certain information. I says, no, we're going to give it to you digitally on your iPads. And so we were able to do that using ArcGIS.com, which you can go down there and make a personal account and use the map information yourself right now. It's a free service personally. For us, they charge us because we're an organization. But for personal accounts, there's still no cost to that. So that's just a view of that application pulled up on an iPad. And when you do that, it makes it kind of tablet or a mobile accessible. You can use your pinch zooms and out, tap on property and get information. So that's a lot of two-dimensional and somewhat, you know, we had a little bit of 3D in there with the pictometry, the angled imagery, but what excites me about geodesign and into the future is the ability to start looking at stuff in 3D. Because many of the, you know, talk about, well, if you're going to model the Earth, the Earth is three-dimensional, multi-dimensional. It's not two-dimensional. So let's get to the three-dimensional, at least three-dimensional aspect. And with a new product that they've recently purchased and are really starting to put a lot of development in, specifically called City Engine, gives the ability to create three-dimensional models fairly easily. I say that, never have made one. So that's what they say. That's what they tell me. So we'll see if I got connection. So this is a model that you can pull up if you really want to know. I can give you the steps on how to get to it, but it's being served out through that ArcGIS.com gallery. So they have a lot of services and maps that are produced that you can get access to, and you can pull this three-dimensional view up. And this is out in Philadelphia.
Are you looking for a lifestyle? Consider this: a place to find your career, a place to do business, a place to raise a family, a leader for tomorrow's economy, a place to live and learn. Consider Iowa. Find job search tools, career planning resources, and explore Iowa communities online. Find your career, find your lifestyle. Learn more. Visit consideriowa.org.
The Hawkeye Wrestling team is ready for the 2013-2014 season. How about you? Get ready by purchasing your season tickets today. For only $85, the Hawkeyes host wrestling powerhouses Oklahoma State and Minnesota at Carver Hawkeye Arena this season. And Tony Ramos, Derek St. John, and Bobby Telford want to see you there for another electrifying season of Hawkeye Wrestling. To purchase your tickets, call 1-800-IA-HAWKS or visit HawkeyeSports.com for more information.
You're going to have a 3D card.
Why are you taking it, Tasia?
So the key thing here is that
So you can get in there and start rotating the image around. And what this one is trying to promote is a proposed development. So this building here, and we can click on it. So it has information. It's not just an image. It has data. It has intelligence. So you can click on that building. Go back there. And that's a proposed development. So if to the right here, you see this redevelopment, that's the proposal. You can click it off and see what's there now. Okay, so you can toggle it back and forth as far as what's there now and what is being proposed. Once again, you can click on any of these buildings and get information about what it is. It has programmed fly-throughs in it. Now this is the end product. It takes a lot of effort to get to this point. I'm not saying this is easy to do. This takes a lot of time and effort. But the software is getting there. It's getting, in the university with the new licensing agreement, will have access to this software, this City Engine product. So it's incredibly encouraging to see this type of developments, because this is really getting to the point where Ian McHarg's vision is being realized, where it's building these models, building collaboration, ultimately with the effort of saving the world, or at least helping the world develop in a more sustainable, natural way. Thank you very much. Any questions?
So is this view LiDAR generated?
This particular view is built using somewhat, if you're familiar with Google SketchUp tools, if you're not, it's basically these buildings were used by very intelligent software that's actually being used in movies. Recent Superman movie used it. Cars used this technology to build these landscapes because you can do it programmatically to a big degree. You can build in intelligent, so you can build like a building location, but then you can plug in all the specific information about it. So where it used to take a lot of time to go in and build each one of these buildings, you can now build them with pre-existing displays or facades. I mean, it's pretty crazy what they can do. So LiDAR possibly could have been used to build some of the elevations, but I think a lot of it was built from the ground up and just saying this is what the building looks like.
So you just say, you have the bird's eye, and so you just say it's 8 stories, it's concrete, the windows are square. That's all in the program.
Yeah, exactly. So yeah, it's pretty interesting stuff. And obviously there is that the LiDAR, the underlying elevation, I'm sure it was used for that. But as far as building the buildings, they were probably built using programmatic software.
This has been used. We had a few years ago a person who came here and spoke about reconstructing ancient cities like Egypt, the Karnak, the temple at Karnak and Luxor, and Thebes and Memphis, that you can redesign what ancient cities look like. They also do this for the Middle Ages too, but cathedrals or castles that no longer exist can be and you can look at it from all sides like this. But this seems to be the latest stuff. This is even more advanced than what we saw like 2 or 3 years ago.
Exactly. Yeah, they've really made some big improvements in the ability to create these landscapes or these cityscapes quicker than they have. It's pretty cool.
When can we expect to see this for Johnson County?
Tomorrow.
Okay.
No, I'm working on it tonight.
All right.
And that's what's kind of interesting because hopefully we can get something within the university, in either the Urban and Regional Planning Department, the Geography Department, a joint effort to start building a cityscape for Iowa City and Coralville and other areas.
It used to be that a picture was worth 1,000 words. Now it's these 3-dimensional fly-throughs that are worth millions and millions of words. It's a great selling point.
It's 1,000 here.
Yeah, exactly. There you go.
So in the developer version of this, say you're looking at this building, would you have the ability to say, on that floor area ratio, give me 8 more stories, give me 3 less?
Yes,
see what it looks
exactly. Very easy. You grab that object and you say, okay, add 8 floors to it. And it pops it up. And just to see maybe what it does to the view shed, or what shadowing effects, and what's kind of really neat is get out of here. You can turn things on and off. That's right to light. Shows your base map. There's a way to adjust the shadowing or the sunlight throughout the day. So,
would have been useful when they're finding out in London that those buildings are melting cars.
yeah, exactly.
Where the light was going to be coming from.
Because this takes you through the day. It takes the light source and it rotates it around the buildings. So you can see where the shadows are going to be at a particular day, and even, you know, a particular month, because the sun angle is going to be different based upon the month or time of the year. So it's fun stuff. It really is. I'm excited. I mean, I want to justify it more at the county. I mean, Johnson County, we're more, we can't just do a lot of this fun stuff, because we're tax supported, but I think there's a lot of opportunity with the university to build some of this stuff.
Well, the university's used some of this technology, haven't they, for their building projects, because they recently showed us at the art school, the new building that's going to be next to the Art Building West, that they're going to build a new studio building, and they show kind of just like inside, you can go up in all the rooms. And they did it for that public health building too. There's online right now. You can look at the new public and go through it even before you enter the building.
Because what this new product is built into the GIS software. So when you purchase, I think it's our GIS 10.2, a lot of this capability is part of the project. Probably maybe some of that art was done by the architecture, some architecture. So it's a little bit. Sorry, I keep falling asleep on you, but this is built in to the GIS software, so you're utilizing kind of architectural based software along with GIS software. So you're bringing those two together. Once again, the geodesign effect, where you're able to model the earth and the environments as accurately and as well as you can, and also making them available. See, that's the key. Is for years, three-dimensional development has been possible, but it's been pretty hard to share it. Once you build it on a computer, it's hard to get it out on the web. It's hard to take, to share it, because the images or the databases are extremely large. Where this makes it deployable, where you take a snapshot of an area you're looking at and then push it out to a web, site like you see here, and once again makes it more accessible.
So the 3D map is dependent upon the area basin, and then this other information on building practice.
It's building, yeah. So
and how well developed is that layer of information?
Like within a city, it's extremely detailed and developed because it's based on building footprints that were mapped.
So is that
GIS program?
Is that an Esri base layer? If you want to pull that in, you want
to Esri? No, that'd be an individual organ, like a city's-based GIS system. So, anything else? Like I said, I could talk about this all night. Well, maybe not all night, but yeah, it's exciting stuff. Once again, like I said, it's becoming available. This technology. I was at the ES Rice conference last summer in San Diego, and they talked a lot about this technology. They talked a lot about geodesign and how it's an effort that they're trying to do to take GIS, because a lot of people out there, you hear the word GIS, they really don't know what you're talking about.
Could you let 5 matriarchal buffalo loose on that planet and see what they're
Heck yeah, that'd be awesome. We need to work together and let them loose in Philadelphia and see what happens. Here they go. Yeah.
Google SketchUp also uses a lot of geodesign.
Yep. I mean, and that's what this is evolving from, or that's
evolving from this.
Yeah. Well, like I said, Google SketchUp has been out there for a long time, but this, once again, this provides intelligent objects, where Google SketchUp more likely is just an object, a visual object, maybe with some tags. Where this, you can query it, you can modify it. There's a lot more, once again, intelligence with the product. Thanks again.